Assalamualaikum. Assalamualaikum. Very good morning. Can you hear my voice?
Can Doctor.
Boleh? Alright. Okay. I'm sorry for the delay. Right. Let's begin the class. I hope ada hiccup lah. I try setting banyak kali ni tak masuk. Oh. Alright. Okay, kita stop dekat corrosion in steel last time. Okay. Alright. Remember when we talk about electrochemical reaction, okay, when we talk about electrochemical reaction, you can see here the metal is corroded when it releases electrons and form ions. And then that will happen at one side. And another side, what will happen is there will be another spontaneous reaction at the cathode. Okay, so at the cathode, it can be happen at different medium. Okay, number one, in acidic medium, okay, where H will receive the electron donated by the metal, okay, so this metal electron will transfer and passing through the conducting media, which is it is happen where the presence of connector means that the electron will passing through the connector. If it is happen through body, so the electron will passing through body. All right. So this electron will receive by the hydrogen. Okay. So this is happened without the oxygen, without the oxygen. And if okay. And if the acid contain oxygen, the reaction involve oxygen reduction, where the oxygen molecule will receive the electron, okay, the oxygen plus hydrogen from the acid and forming water. Okay, this is condition in the acid. Besides, if the media in neutral like water or in alkaline media, okay, the oxygen plus water, okay, will do the job, which is the reduction to form hydroxide. Okay, so this is the electrochemical reaction that will occur. So now let's take a look at the water. Okay, and the water, the rusting of the steel. All right. Previously, last class, I have in brief, show how the rusting occurs. All right. So corrosion, okay, the first example is the acidic condition, all right? Remember acidic condition, it can be with the limited oxygen or concentrated oxygen. So let's assume in this situation, it's contained oxygen, all right? Okay, so the iron, okay, iron is the metal. The metal will reduce, the oxidize into Fe plus 2. The electron, how much electron will release? It's 2. And then at the catalytic reaction, okay, the oxygen plus H positive charge from the acid will form water, and there is an additional reaction, okay, which is hydrogen bubble produced. So this we call it electrochemical reaction. Remember, okay, what is metal ion? Metal ion is coming from the iron ore. What is iron ore? Iron ore is the original state, the stable state of iron that uh, we extract, we do the job, we allow the reaction, and we give a lot of energy to convert into iron peak, and then up until the oxide turn into a metallic ion. So from the oxide state into the metallic ion, it's we induce a lot of energy. So now it's because of the nature, its original nature, when there is a presence of oxygen, it will reverse back. And when the first step, the oxidation occur, it will occur from iron, metallic ion into Fe plus 2. Remember, metallic bonding, okay, consists of electron moving freely moving between the atoms. So these electrons are very energetic and easily react with the environment. So once the first, at the end of the reaction occurs, reduction goes to Fa plus 2. However, it is not yet stable. There is another anodic reaction follow, and it will be Fe plus 3. Okay, so the follow chemical reaction is, okay, Fe plus 2 become Fe plus 3. Okay, so this combined with this reduction, the what we
Doktor tak dengar lah doktor, suara doktor hilang.
Okay, boleh dengar tak suara saya? Sorry lah, saya punya komputer, internet apa semua ni tak berapa mesra alam lah.
Boleh.
Boleh dengar suara?
Boleh.
Okay. Tak apalah. Slide saya tu you all ada kan dekat e-learning. Semalam pun saya update sikit. Dia ada sebenarnya ada dua jenis, satu LCD, satu dalam neutral environment. So pakai whiteboard je lah. Right, bila saya share screen pakai iPad, sekarang saya pakai iPad, saya rasa macam dia tak boleh record. Okay. Alright, so nampak saya punya whiteboard ni?
Nampak.
Nampak tak?
Nampak.
Nampak Doktor, nampak.
Okay. So, corrosion, or we call it rusting, in iron or steel. Okay, when we talk about steel, this is iron plus carbon. So whatever we have in our metals, so basically whatever the alloy that we have, for example, in this case, the steel is alloy. The steel is alloy. However, in the alloy, there will be one element that will be more easier, okay, to corrode. For example, in this steel, we have iron and carbon. So between iron and carbon, okay, iron are more sensitive to the environment because of the galvanic potential. Okay, I will explain later what is galvanic potential. Okay, if I'm sharing my slide or my screen, I think I cannot record. So is there anyone that would like to volunteer to record the session so that you can share with your friends? Ada tak? Boleh tak? Anyone who would like to volunteer record?
Boleh Doktor, boleh.
Boleh? Boleh? Siapa tu?
Saya Francisca.
Siapa yang nak tolong record ni?
Francisca
I
record.
tak dengar.
Francisca record.
Okey lah. Ada yang dah volunteer tolong record Alright. Okay. So, alright. So now this still basically how it's happened, the corrosion happened. Okay, sorry lah. Tak berapa nak mesra lah internet hari ni. Okay, boleh dengar suara saya? Okay,
Yeah.
so when you have a steel, this is your steel, there is a water here, okay, there is a crack here, okay. This situation will be the main cause of the corrosion happen. Okay, it is not as simple as you have a steel and then it will corrode. Maybe yes, but it will take longer. However, when you have, of course, you have a product, a steel product, and then after you use some time, there is a scratch somewhere here. So basically, the scratch or crack surface will be the initiate point to allow the corrosion to occur. All right, so now if we have a surface with the defect, okay, with the defect, and we have the water here, okay, so and of course surrounding there is a oxygen, or maybe in the media of acid, okay, in the media of acid. So for this situation, the corrosion will occur. Besides welding, okay, in the welding. Why welding? Because let's say we have two metal piece number one, and then the metal is number two. So we join this metal piece with a welding. Okay, the weld will join this metal piece one and metal piece two. Okay, when they join, there's so many stress concentrated somewhere here. Okay, we call it heat affected zone. So at this point, it will become the weakest point of the structure. So this region, if there is a water drop, of course, our environment contain the moisture. Okay, so there is oxygen and water. So the moisture is oxygen and water. So if there is a this meaning that not in the vacuum condition or not in the argon condition. If this metal piece is located under the argon condition, of course it will protect it from the corrosion. But if it is just exposed to the ambient condition, meaning the corrosion will occur. So this weakest point, the steel with the defects, the water and the oxygen will let the corrosion happen. So when the corrosion happens, the oxidation in the redox reaction or electrochemical reaction will turn Fe into Fe plus 2 and then Fe plus 3. Okay, this is what will happen. All right, so the first oxidation reaction and then the third oxidation reaction. All right, so now let's take a look at the reaction. Sorry. Okay, in the remember what is the reaction that happened? Redox is electrochemical reaction. You dah belajar ni kan? Yang laju-laju pun boleh ni. Electrochemical reaction that involve reduction plus oxidation. Okay, all right. So the steel, of course, will oxidize. Oxidize, so means that it will turn into plus 2. Okay, plus 2 electron. Okay, so this is oxidation number 1. Okay, all right. So so since the ion release electron, okay, someone will take the electron. Okay, for the someone to take electron, okay, the oxidizer agent in this case is the oxygen. Okay, if in the acidic condition, remember in the acidic condition, let's say we take the first example in acidic condition. So the oxidation oxygen will reduce. Okay, of course it's plus H, and then it will receive electron and the product is H2O. And if we make it balance, let's get okay. How to balance this one? H of oxygen, dua here lah. Okay, so this will be 4 and 4 electron. Yeah. So this is the first reduction of the dots. Okay. And then remember this Fe is not stable. They love to form, to go back to its original condition. What is it? It is Fe2O3. Okay. To get this Fe2O3, it must turn into Fe plus 3. So you need to turn into Fe plus 3. With that, you will receive a second oxidation, which is Fe plus 2 turn into Fe plus 3 plus electron. Okay, so this is oxidation number 2. Okay, and then yeah, remember the additional in the slide we have an additional catalytic reaction. Okay, reaction 2. It is the hydrogen will produce during the reaction the hydrogen gas. So of two reduction 2. And this is a electrochemical reaction. Chemical reaction. Okay. Oxidation 2 and reduction 1. So the chemical reaction is a combination between this. So before we directly combine them, we need to balance the equation. So 4 electrons, 4 electron, and 4 electron. All right. Okay, so we can easily just cancel this one. So oxygen 2 plus 4H plus 4 Fe plus 2, and it will produce, oxidation dulu. Okay, oxidation dulu adalah part Fe plus 2. Kita nak oxidation dulu. Okay, and next is reduction, which is O2 plus H plus, and produce the 4Fe plus 3 plus 2H2O. So this is chemical reaction that will occur in the acidic condition when the steel is rust. Okay, so this Fe plus 3 will combine with the H2O to produce the rust. So 2Fe plus 3 plus 4H2O, okay, will produce Fe2O3 plus 6H plus. Okay, so for this case, how it become 4 and 2 is just to want to balance this reaction. All right. This is a situation where the corrosion will occur. How the two oxidation occur? Okay, first there is a weak region here, so this will be anode, and the region near to the oxygen will be cathode. Okay, which is a positive charge lah. This is negative charge. Right. The oxygen coming from the outside, and this will release the ion, and electron will move here. And here, what will happen is the reduction. Reduction will happen here. So Fe2 plus again reduced by the oxygen to produce Fe plus 3. Okay, reduced plus oxidize. And then it will form into at the cathode into the rust. Okay, another example is the corrosion. This one is, I think, the normal situation where the rusting happen in the ambient condition. Okay, of the steel in neutral or alkaline. Okay, the condition that allow the rusting is still the same. You need Fe plus O2 and H2O. Okay, these three elements is needed in the reaction. All right. In this reaction, remember in the alkaline, alkaline solution, the final reduction reaction will produce hydroxyl. So the first oxidation is still the same. Fe will turn into Fe plus 2 electron. This is oxidation. Okay, and then in the cathode, okay, at the cathode, the oxygen plus H2O, and then it will receive the electron to produce hydroxyl, okay, hydroxyl. So now we have 2, 3 to make it balance. We have 4 and 4 electrons. Okay, so this is reduction. This reaction we call it electrochemical. It's involved redox reaction. Okay, the next is when we have this when we have this Fe ions and OH ion, so it is totally chemical reaction. So the chemical reaction involved here is the formation of what we call it iron hydroxide. Okay, iron hydroxide. It is not stable. It is not stable. So if we combine this and balance the reaction, we will receive this one will become 4, 2, and 2. So the 2Fe, okay, plus 2 sorry, plus O2 plus 2H2O. Okay, this one can be cancelled. Will produce 2Fe plus 2 plus 4OH. Okay, so remember this is chemical reaction. So in corrosion, it requires two reaction. Number one is it is a redox or electrochemical reaction, and number two followed by chemical reaction. So when it's form a chemical reactions, meaning that it will produce if we do the factorial for this one, we will get Fe plus 2 plus 2OH minus, so OH is negative. So a different configuration, so AH is 2. So this is chemical reaction. All right. However, the remember Fa iron plus 2, okay, is not stable. Not stable. Okay, the two FeOH that we produce through the chemical reaction, okay, later will reduce by the oxygen, reduce by oxidize. further oxidized by oxygen. Okay, because iron 2 condition is not stable. It loves to turn into its original condition, okay, which is in the oxide form rather than the hydroxide form. So well, he will turn into its oxide condition plus the water. Okay, the oxide condition, if this is oxide, iron oxide. Okay, but there is a water. How many empirical value of water is unknown, X, and it is H2O. Okay, so this guy we call it hydrated iron trioxide lah. Hydrated, pada ada water ni. 3 because it's oxidized into positive 3, and then oxide. So oxide, why oxide? Because this is oxide. All right. Okay. So this is the final product. If we rewrite again the equations, so we have what is it? This is the original 2Fe plus O2 plus 2H2O. We produce Fe2O3 H2O. Okay, ni bolehlah balance lagi. Tengoklah macam mana nak balance ni. Kita boleh letak dekat sini dua dulu kan. Dua. Okay, and then bila ini dua, ni akan jadi. Ini sebab kenapa kena dua? Sebab H2O dengan oxide. H2O dengan oxide kena balance. Okay, okay, question saya ni. Tinggal mana oksigen satu. Okay. So dua kat sini, oxide ada oksigen ada dua, so dua sini lah kan. Sebab ni dah ada 6, ni 6, ini 2, ni 4. Okay, balance. Good. So ni kena jadi 4 lah. Okay. So 4, 2 dan silap. 2 H2O. Okay. So ni 2 H2O, 3 campur dengan 2 campur dengan 6, 8. So on 3 lah. Okay. Okay, H2O ada 2, oksigen ada 3. Oh, okay. Sorry. Okay pula. Okay, ni oksigen 3, so 3 lah sini kan. 2, okay betul Ni 4, dia dah jadi 4. Ini oksigen 3, water 2, oxide 2, dan ini adalah X. So bila 2 kat sini, kita letak 2 dot kat sini, so sini pun 2 lah. So ni X. Nak make balance water here, so kita kena letak kat sini X lah. So bila rewrite balik, 4 Fe plus 3O2 plus 2X H2O produce. Oh tak penting, jangan risau sangat lah. The equation dia yang penting, the final product is hydrated trioxide. Okay. So I'm not going to test or assess your ability to write the chemical equation in this course. Ini chemistry punya kan. So some of you, I believe some of you are very phobia with chemistry. So in this course, we are not going to assess the chemistry level. So the 2Fe2O3 dot X H2O. Okay. So this is final equation. So now the thing is, from the iron, there is oxygen and water in the neutral and alkaline solution. It will produce what we call it iron oxide in the hydrated condition. So hydrated iron trioxide, we call it hydrated iron trioxide. So this is basically what will happen. And then remember, this is happen at the condition where you have a defect. you have defects. So for example, you have a crack somewhere here, okay, and then there is a moisture, there is oxygen, this is your steel. It can be any metal, aluminum or whatsoever. Okay, and these are going to be anode. When you have anode, this anode will be oxidized. Okay, it will oxidize, it will release electron. The electron will go here, and what will happen is Fe plus 2. Okay, and the electron here will be donated to the oxygen and water to allow the reduction occur near the interface between the water and the oxygen. Okay, so this is the interface where we have the water and oxygen concentrated. Okay, this region is less oxygen. So there are two different oxygen concentration. This is high oxygen concentration. This is less oxygen concentration. And you have a stress somewhere here because of the defects. If you have defects, let's say you have a load somewhere here, the load motion will be concentrated here. Okay, the load path will be concentrated here. So high concentration, it will generate more easily force. It will force ion to make it easily release the electron. Okay, why? Because of the process of the catalyst, which is oxygen and moisture, and then it will produce a rust here at the interface between the metal and the oxidizer. So this is how the corrosion will occur. Right. Okay. Similar to the other metal like this one. Okay. So this is electrochemical when the zinc in the acid. So zinc, okay, when at any condition when one region become anode, the anode will allow zinc to release electron to produce zinc 2 plus or zinc plus 2 in the oxide condition. And then the electron will go through the region where it's assigned the surface or the region into a cathode region. Anode and cathode basically assigned due to the environment condition. Just now in the steel corrosion, you can see the example of how anode and cathode is being assigned because of the different oxygen concentration. Okay, different oxygen concentration, it's automatically assigned one part into anode, another part into cathode. Okay, so a different potential of the region will make it will force will allow the electrochemical reaction to occur. And when the electrochemical reaction occur, it means the metal will corrode. Okay, so right. Okay, ini dah sudah. Okay. Right. So now you understand. You understand that we need to have the anode and the cathode, and there is some path that allow the electron to move. If we stop the path, the corrosion will not occur. And then what else? What else that will contribute to the corrosion? We need anode, we need cathode, we need the electron path. What else?
Electrolyte.
Yes, good, electrolyte. Okay, this is example that okay, 4 requirement is needed. Okay, in this example is in this picture, it is a pipeline. Okay, we have thousand kilometer of pipeline in Malaysia. They are in buried in the underground. It's submerged in the water, in the seawater, installed in the brick, in the buildings. They are everywhere. And what materials that dominant in this pipeline making is the steel. Why? Because the good properties, the strength, the fabrication, the abundance of materials, cheap, the abundance make it cheap, and the versatile properties of the steel. So in the metal itself, logam, about 70% is steel. Okay, so and we can recycle steel. And why this situation happen is because the steel making is already dominant earlier than the other metal. So the processes and everything is become cheaper and cheaper when the technology evolves from one time to two time. All right. So steel is the most essential metal, the most important metal, and it's widely used. Only the problem compared to the other metal like aluminum or other other less abundant material, the steel will easily corrode. Okay, easily corrode. After several hundred years, people have developed method to prevent the corrosion. It includes the coating, alloying, and so many methods to prevent the steel from corrosion. So now you understand that electrochemical reaction require this. Now you understand that corrosion is electrochemical reaction. The mechanism involved in corrosion is um, electrochemical mechanism. So to allow the electrochemical reaction to occur, you need anode, you need cathode, you need path, you need electrolyte. Okay, so between anode and cathode is one physical metal surface or metal body. So between anode and cathode, which one will corrode? Which one will corrode? I'm sorry, I couldn't hear you.
Anode.
Anode, okay. Anode will corrode. Okay. So if you have a structure that you want to protect, you must not allow the whole body turn into anode. Okay, you have to ensure this, the whole structure is not anode. You must assign it, turn it into cathode. Okay, that's the reason you need to learn corrosion course. Okay, so in this figure, okay, pipeline is the steel. It attached, okay, they are apart. Okay, a copper wire connector. This is a connector that allow the electron to pass through, and usually is a copper wire. Okay, connect with this metal, and this metal you need to know what is this characteristic of this magnesium. It must has a specific characteristic that allow it to become an anode. So when there are two dissimilar material, they join together. One of them has a higher galvanic potential. One of them has lower galvanic potential. I will explain later what is galvanic potential. So higher or lower will um, will turn one of them become anode, and automatically another counterpart is will be cathode. Anode and cathode, they must be coupled. If one of them become anode, another one will automatically become cathode. So now your pipeline will become cathode. So as long as this pipeline become cathode, it will not corrode. It will not corrode. Okay. Of course, to double protection, usually we will coat, paint the surface, or we coat with a polymer tape. Okay, polymer coating with paint. Cat lah kan, mana ada kita nampak pipe. Have you ever seen a pipeline? Yeah, that the giant pipeline at the highway or anywhere, or buried in the underground. It's just a bare still, without painting, without coating. Never. There must be at least a paint surface, and after some time it will repaint the surface to avoid for the corrosion. Not just painting, not just painting. Look at your the grill at your house, the grill or your gate, your steel gate. Okay, after some time, the paint will be degraded. Okay, the paint will be destroyed and expose the metal part, the steel part, to the corrosion. Okay, meaning that painting is not sufficient. Besides painting is just to avoid some defects. Okay, occur. Basically, we will provide a double protection. One by electrochemical design, another one by what we call it, protective layer. Okay, protective. Directly, the paint actually will stop the interaction between the steel and the surface. Okay. It still can be protected by placing it in contact with more active materials like a magnesium. Okay, magnesium will it's a more active metal relatively to steel, and if it is active metal, this metal will be sacrifice itself and do the job of oxidation. So Mg will do the anodic reaction, so it will oxidize into Mg plus 2. Okay, and it will release electron. Electron will pass through the connector and go to the cathode. When it go to the cathode, okay, if it is acidic condition, it will produce the water. Okay, all right. Again, requirement for corrosion to occur anode. Okay, or anodic site. Anodic site ni maksudnya not one single piece of anode, but on the same surface, there will be one side that associate with anode. So either one piece of anode or anode side on the surface of the metal. Okay. So in the anode, oxidation will occur. What is oxidation? Oxidation is actually the corrosion that occur on the metal. And then the cathode, okay, the cathodic side on the surface of the metal, where it is an electrode on which reduction will occur. Electrolyte, okay, and then the electrical connection, okay, the connection, that media that will allow the electron to pass through. Okay, I think that's all for today. We have finished our second week lesson, which is corrosion mechanism. You need to understand corrosion mechanism because it is widely applied in any type of corrosion. Okay, let me give you one example. Okay, when I work in one electronic company, they produce metal part that made of stainless steel. So they believe none of their metal component will corrode. They believe none of their metal part, their component will corrode. So everything will be corrosion resistant because they use stainless steel. Okay, However, the customer complains that the product contains corrosion. Okay, what component? They have a one metal part like this for the hard disk, and then there is a screw. This metal part. Okay, both are made of stainless steel. Okay, and they found a corrosion here. That is corrosion. Right? Now what happened? Both are stainless steel. Why it is corrode? Okay. Biasalah masa saya kerja dulu, bila nampak macam pelik macam ni, diorang mesti doktor, dia akan datang pada saya. Okay. And I asked them what materials that they use. They say, oh, stainless steel. No. What exactly is stainless steel? Actually, there are two different grades of stainless steel. Okay. If it is still like this one, it is easily understood. Okay, because it will easily oxidize. One of the surface, if just less oxygen that give a different concentration of oxygen, will automatically assign one part as anode and another part is cathode. Okay, sekarang je. Asal ada kurang oksigen saja, dia dah boleh jadi electrochemical reaction. Macam mana boleh jadi electrochemical reaction tu? Sebab less oxygen akan jadi anode, more oxygen, high concentration of oxygen akan jadi cathode. Senang macam tu sekali. But stainless steel no, because the steel will don't do the oxidation job. Who will do the oxidation job? Chromium inside. Stainless steel is iron plus chromium. So the chromium will do the oxidation. So it will sacrifice themselves, and when it sacrifices themselves, it becomes oxide, and it is okay if a chromium becomes oxide. Okay, why? Because chromium is very shiny, smooth. It will form a very continuous, uniform protective layer, not like a steel. Steel kalau jadi oxide, dia jadi oxide yang sangat jahat, bad oxide. Okay, see, iron oxide is a bad oxide. Chromium oxide is a good oxide. So now back to the problem here, the complex engineering problem. I asked them what actually the stainless steel material. Then we found the answer. What is it? The screw is a harder stainless steel material. Okay, harder stainless steel material. It's magnesic stainless steel, and this metal part is, if I'm not mistaken, is ferritic stainless steel. It's a bit soft and easily to be deformed because they need to make it into a specific process. So it needs a ferritic stainless steel. Okay, this one is the screw is magnesic, harder stainless steel. So what happened is, when even the different grade of stainless steel, okay, will assign one of them as an anode, and another one will become cathode. Okay, because of different galvanic potential. So corrosion still occur, and what they need to do, okay, they need to ensure very minimum galvanic potential difference. Next class kita akan belajar ni lah, galvanic potential. Alright, so if you want to choose two different material, make sure how active one material compared to the another is very different active level. Okay, just now in the pipeline, okay, we have a steel structure and we can G, and it's more the is much different. Right. So you need materials in between that they are very different nice materials with bitter. So however, if a very small gap between the reactivity, then you will minimize the corrosion. Maybe just using a very minimal protection, for example, put the grease between the surface kids. I have two kids now, learning from home. So they are also online, me also online. I would like to apologize for that. I hope today's class you can understand. If you still don't understand, your friend later will share the video. And if my video is not so good, don't worry, you will find a lot of video that explaining about electrochemical mechanism, okay, corrosion mechanism. There's a lot. There are class for if you are Indian, you are more comfortable with Indian English. There's a lot of videos from India, especially from IIT. IIT is very high prestige university in India. Okay, the good professor, they will be able to explain you in very detail. In fact, you can find an animation video that explaining about the electrochemical reaction. Last video that I shared with you, also I got it from the animation video from the internet. So there's so many resources, not like in my time last time, we only reliable at one time face-to-face class session. And for corrosion course, I really dedicated at that class by carrying the tape recorder. You know, during my time we have like a Walkman. Pernah dengar tak Walkman?
Yes, pernah.
I carry my Walkman and record my lectures class. At that time, Professor Hamza, I record her voice and then carry back to my house and then regularly listen to the recorded tape. So sangat klasik lah, tak ada indikator apa-apa. Memang kena catat betul-betul atas kaset tu. Kalau tidak nanti saya hilang. Kalau macam sekarang ni kita Google je keluar. Tak payah save, tak payah apa. Masa tu memang sedih lah sikit kan. Kalau terkoyak je tape tu, jenuh lah nak seletek balik, tampal balik. Lepas tu nanti dia hilang lah dia punya suara dekat tengah tu kan. Okay, ni memang zaman lama sikit lah saya punya. So sekarang ni you boleh just Google anything, everything ada kat internet tu. Jangan risau kalau tak pandai. Okay, kalau tak faham saya ajar. Saya pun tak bagus sangat ajar. Tapi you all ada macam-macam resources. Especially ini dah semester ke berapa kita PDBR pula. Kita online learning. So I believe after sometimes your computer tu dia dah pandai dah. Dia dah tahu dah you nak cari apa. He knows what your preference. So before during the first PKP, during the first online class, you search the keyword and you don't find the answer easily. But after 3 or 4 semester, your computer knows what your preference, because AI kan dia ada learning, self learning. Okay, apa yang panggil saya pun tak ingat lah. Okay, so I think that's all for today. Thank you so much, and I hope if you don't understand, you need to do the extra efforts. And if you don't understand, you can ask me anytime. Okay, you can WhatsApp, share the group, the question, and I will help you to answer the question. Okay, if you have nothing, I think that's all. The class is dismissed. Assalamualaikum warahmatullahi wabarakatuh.
Madam, can you share the QR code for the attendance?
Oh, tak ni lagi. Alright. Sorry
Sempat.
Tak sempat. Kat komputer tadi kat iPad tak ada lah pula. Okay. Ada Facebook semua. Okay, siapa yang tak scan lagi, please scan your attendance.
Attendance
Alright.
close. Dia tulis dah.
Attendance close.
Ni yang untuk 4 PM.
Ni betul show ni.
Yang sudah scan tapi attendance dia tak
Oh, saya-
record.
Error tadi. Okay. Sorry. Saya generate balik memang error lah. Memang ada. Kejap. Saya settlekan sekarang. Okay. Alright. Scan sekarang. Nampak So, you all boleh check your attendance dekat UTM Smart. Make sure your attendance is 80%. Okay. Kalau tak 80%, macam mana you kena faham sendiri lah. You tak boleh duduk sit for final exam. I nak monitor percentage tu. Boleh lah. Okay. 3 kali tak datang, first warning. 6 kali tak datang, second warning. 9 kali tak datang, disqualified. 9 kali tak datang, third warning. 10 kali tak datang kelas, disqualified untuk final exam. Okay, you datang boleh, nak ambil exam boleh. I tak halang, tapi you tak akan dapat markah. You akan fail automatic. Okay. So, macam kita pergi kerja lah kan. Dah banyak kali tak datang, takkanlah bos you sabar lagi kan. Mesti kena buang kerja, confirm. Okay, kalau tak ada apa-apa, thank you so much. See you again next week.
Thank you, Doctor.
Sama-sama.
Thank you,
Welcome.
Doctor.
Yes. Welcome.